And now I'm going to share my screen. Okay. Okay, everybody should be able to see my screen now. Let me know if you can't. And this week we are going to be looking at files. Files are a huge part of programming. Sorry, I shouldn't be going up and down like that. So files are a huge part of programming. And why? Well, because everything that we have done up till now in this class that has involved any form of data input has, we input the data, we process, and then anything is lost. When the program exits, the data goes away. And that's not what we want. We want to make sure that data stays around. All databases are files. Whether you have a big Oracle database or you have a small MySQL database, they are all files. Everything that goes on in that database is persisted to a file. Now that file might be written in a non-human readable way, but it is in fact still a file. So that's why files are important. When we want to persist data, it has to be written to disk. And writing to disk means that we write it to a file. So let's talk about the process of writing a file to disk and reading data from a file. The first thing that we have to do is we have to open up a file. And that's just what it's called. It's like opening a book. There is an open command for files, and we'll see in a second how to actually access something as a file. And so the process is create, read, update, delete. We talked about that a little yesterday with dictionaries and lists. The same thing kind of happens for files. A file has to be created. If you want anything out of it, you have to read it. If you want to modify it, you have to update it. And if you want to get rid of it, you have to delete it.
The recording has started. Please announce yourself.
Okay, I'm going to mute people. Let's see. I think everybody is muted now. Okay. So a file is an object, and we're going to learn a little bit more about objects next week. Well, we have dealt with some objects like strings. String is, in fact, even though it's a type, it's also kind of an object because you have functions that you can do on a string, like replace or split, things like that. Well, a file follows the same kind of pattern. A file is created when you open it from the disk. So basically what you have is you have what's called a file descriptor. And the file descriptor is the piece of information on the file system that makes that file unique. Every file on the file system has a unique ID. Okay, and it's not necessarily the name of the file, it is simply a unique ID that can be accessed by the internals of the operating system. So when you create a file through Python, you're really reading and writing and communicating through the operating system. Now, one of the nice things about Python is that you don't have to be really close to the operating system. So you don't have to do anything special if it's a Linux system or a Windows system. It can, or a Mac, it can simply be an open. So what we see here in creating a file object is basically that we are opening a file we're going to read something from the file, and we're going to close the file. Now this line right here, close, is very important. Every computer has limited resources. There's space and speed. And when you're running a Python program, you need to manage some resources. Now, things like RAM, we don't have to manage that in Python. Python does that for us. One of the things you absolutely have to manage is the number of open file descriptors that you have. When you see this chain here, open, read, close, or it could also be write, but for every open, there has to be a close. Now this may not affect you hugely in this class. You may just get a couple points off if you forget to close it. But when you go out and you're programming in the real world, you have to remember to close these. You get too many file descriptors open and all kinds of stuff can just stop happening on your system. Because file descriptors are for everything running on your system, not just for Python. So this close is very important. You are returning a resource to your computer. So for every open, you have to have a close. Just like that you have open and close parentheses, except the syntax checker won't catch this. This is something you have to be aware of and be cognizant of. So there are different ways to read stuff from a file. And why don't I just go open up my PyCharm. Sorry, this shouldn't be showing. There we go. Sorry about that. I'm going to create a new project, Project 7. Okay. So we're just going to do a couple of simple files here. Okay. Going to create simple file. Going to add a configuration, plus button. Python. Sorry, I should have had this set up before the class got started. Script path. I'm on. Simple file. Interpreter. That's the interpreter. Whoops. That's the. Okay. Doesn't want to select that as the interpreter. There we go. That's the interpreter. Okay. So I'm going to do two things. I've got this simple file, but I'm also going to create another file that's just a text file, okay? And I'm just going to call it test.txt, and I'm going to say this is a test. That's all that file needs for right now. So what do I want to do? I want to open the file. Sorry about this. There we go. Okay. There we go. I want to open a file. I want to read the file. And I want to close the file. So to open a file, I use an open command. So I'm going to say my file equal open test.txt. Okay. And I'm then going to print, just so we can see it, my file. So let's start there. Let's start by running this and see what happens. So this is what I get. This print statement on line 5 is giving me this. It's IO, text IO wrapper, name is test.txt, mode is R, and we'll get back to that in a second, and the encoding is UTF-8. Now the encoding, most of what I do is either UTF-8 or ASCII. and pretty much it's UTF-8. And that's just the character set that you can use. ASCII is very limited. UTF-8 is much expanded. One of the important things here is the mode. You have read, write, or read-write. So a mode of read means that I am not allowed to write any information to the file, and Python will prevent me from doing that. So read-only mode basically means can't change it. Write means that I can put data into the file, but I'm really not going to read anything out of it. And read-write means I can do both. And so we're going to see a little bit more about modes later, but I wanted to introduce that. So there are a couple of different ways to read the file. So if I say my file dot, now I have read, read line, read lines. I'm going to choose read line, and I'm going to say my line, is read line, and I'm going to print my line. So let's see what I just did. And so line 5 is still this. Line 9 is this is the test. So I have opened up test.txt, and I have used the readLine function for a file to obtain the first line of data, and then I printed it out. Now what I need to do is I need to close that file. So my file dot close. This is important because I have to return a resource to the system. And then let's see what happens if I print my file. Let me run it again, and you will see that the descriptor is still there, but it should have been returned to the system. So don't let that make you think you didn't actually close it, because my file still has that piece of information in it, even though it is closed. So that's the basic process. You open it, you read it or write it, and you close it. Now there are lots of interesting ways in which to read a file, and we'll go through some of them. And you'll also notice that my file, that the test.txt, didn't have any formatted data in it. And that's okay, because for right now I don't need formatted data. And a little bit later we'll probably talk about that some. But files in real life, all of them have some form of format, or almost all of them have some form of a format in them. Even the ones that aren't human readable have a format. So I use the read line. I could have just used read, which would have returned the content, all of the content as a string. I could have used read line, which would have returned it as a list of strings. So let's look at that really quick just so we can see the difference. So that was read line, and now let me do this. I'm going to change this and say second line. I'm going to say oops, my bad. So I'm going to say okay, just so we can see the difference in what happens. So and I'm only going to do these one at a time because some of them may mess up how the other ones read. Okay, so I'm going to say read, and then then I'm going to say read lines. And I just want to show you the difference when you're reading a file. When you're writing a file, it doesn't matter quite as much, but when you're reading a file, you need to know what it is you're getting so that you can navigate it. So this is going to be, we did read line, read, and read lines. Okay. And I'm going to do these one at a time because there's an invisible pointer in the files. And when you do these reads, it's going to go down and move that invisible pointer. So if I do read after read line and there's nothing left in the file, I'm going to get an error. So I'm going to do this and this. Okay. So I'm just going to run this. We've seen what read line is, and by the way, notice that there's a hard return here, and that's because I hit the return key before the second line. This only read one line. At the end of that line, there is a return key, so that's what's printing out here. That's why you have open square bracket, this is the test, and then a return, and then on the next line, the square bracket is there. So now, if I do read, just read for everything in the file, let's see what it gives us. And by the way, if you're curious, you can always do this. So this has, this gives me read, this is a test, and then second line. And that's because that's what's there. So this read everything out of the file as one string. Now, these look like they're on separate lines because they are, because I hit that enter key. So now let's look and see what happens when I do read lines. And you'll see that this is in fact, right here, ignore the outer square brackets, that this is in fact a list. So there are three different ways, just by using different functions against a file, to get data out of the file. All of these are very valid. All of these are correct for the right use. You guys just need to figure out what the use is. But there's also other file commands that you can go out to the Python documentation site and take a look at. Okay, so let's keep going. Writing to file. So we just read from a file. So now I want to write to a file. So that's fine, but I've only learned to read. So there's this write command. I can write to a file. And now, here's something very important about close. If you're writing to a file and you don't close the file, there's a very good likelihood that not all your data will be in that file when you're done. So if you're using files and you write and it doesn't look like the data's there, you need to go back and make sure you've actually closed the file. So I'm going to go back here to my simple file, and we've got some reads going on. And now, actually, let me do another file. Oh, okay, come on. There we go. I'm going to call this write file. Well, should have been file. Rename that. Nope. Not what I wanted. Okay. Okay. I'm not going to bother trying to rename it right now. So what I want to do is I want to write a file. What am I doing here? Okay, that's what I wanted. Okay. So I'm going to try and write a file. So the first thing I'm going to do is I'm going to create a new file. Well, let's see how to create a new file. This one, it shows a file that is already existing on disk. But let's say I don't want to do that. Let's say I just want to create a file out of thin air. And I'm going to Google on purpose. I use Google a lot. I don't remember every nuance of every language that I write. There are, last week we had an intern. He wrote some stuff in Python. There was a large set of data that it was supposed to be tested against. I did not want to run all of those data tests. I'm kind of helping him figure out what he's doing and where he's going with the code he's writing. So I wrote a bash script because I have a Linux workstation. So I was writing a bash script, and I don't write in bash every day, so I don't remember everything about bash scripting. So I went out to Google, and I took a look for some of the things that I knew I needed to do, but I didn't know the syntax. So I'm doing the same thing here, because Google is your friend when you're a programmer. Lots of people have done the exact same thing you're trying to do, and the probability is somebody's already figured out how to do it well. So I'm going to create a new file in Python. But let's say I don't know how to create a new file in Python. So there are all these different resources out here about how to create a new file in Python. So I go to W3 Schools, has lots of cool information. So, and here's some cool information. A will append to the end of an existing file. Write will overwrite any existing content. So I bet if I open a file for write, it's going to create a file where none existed. So let's go out and see if that works. So I'm going to, first of all, say new file is open, new file, write. So let's see what happens. And then I'm going to say new file dot write, and I'm going to say this is a new file. Whoops, new, not few, or yeah, few. New file, period. And then I'm going to close it. So I'm going to run this one in the debugger so we can see what's happening. Change this. I don't know why my system is slow tonight. Okay, so I'm going to debug this. Just going to run it through the debugger. And I am in the debugger process. I'm going to go to the console first. And I'm just simply going to step over my first line of code. So now let's see what happens. And I have new file, and I have a text.io wrapper. The name is newfile.txt, and the mode is write. Now, if I look over here on the left-hand side, there's no new file there. There's nothing named new file under Module 7. So why not? Well, my guess is I haven't actually written it to disk yet. I've just created a resource, kind of a pointer, that says, okay, Python, there's going to be this thing called new file, and I'm going to write to it. So now let's see what happens when I step over. Still nothing here on new file. But I have this thing called new file, and by the way, here's all the information you get just for having new file. And then, I still don't have anything over here, let's see what happens when I step over the close. And all of a sudden, I have new file.txt there. And if I open new file.txt, it says this is a new file. So what I have done is I have created a brand new file. I have written some data to the file, and I have closed the file. But that close is what wrote the data to disk and created that new file. Now let's see what happens if I do this again, but I use the same file name. So the file already exists on the system, and I am going to open new file.txt for writing. I'm going to write this is a new file 2 with the number 2, and then I'm going to close it. So I'm just going to run this. Everything's finished. So let's open new file, and you'll see that it got changed. So I can use write to overwrite an existing file, or to create a brand new file. And that was kind of the point I was going for. Write will do either. So, and you can write all kinds of things. Anything you want, you can write. So here are the modes for files: reading, writing, and appending. So appending is different than writing, because appending will not overwrite the contents of the file. It'll simply add any new data to the end of the file. And that's very handy, because sometimes you don't want to overwrite everything in a file. Flush. The flush method can be important, especially if you are writing large contents to a file, or if you're doing a lot of iterations to create a file. Flush will basically take any data that Python is holding that it actually hasn't written it to disk, and it will write it to disk before the close. Now, this isn't something I want you to get in the habit of, but it is important to note, especially if you're doing large processing, large programs. So it's very important. The other thing they talk about here is this buffering. And the buffering is just basically saying the size in bytes that I'm going to hold on to. So when anything is bigger than that size in bytes, it gets written to disk. So when I'm holding, in this example, when Python is holding more than 100 bytes of data associated with that file, it's going to write it to disk. And that's very handy too, because you're not having to do a lot of extra management based on the size of the file. So there are other ways to write data to a file than to close it. One way or another, in the end, you have to close that file. But there are other management techniques. Now, you're not really going to need these management techniques for your project. You're not really going to need these management techniques for the zyBooks lab, but it's important to understand them, especially if you're going to be doing any file management moving forward when you're done and successfully, happily over with the Python class. Okay, interacting with the file systems. So basically what happens is the Python interpreter will communicate to the file system for you. So a lot of lower level languages, C and C++ even, you're closer to the operating system, so you have to be more aware of how the operating system is handling your files. With Python, you don't have to do it. It kind of removes us from the operating system far enough where the Python interpreter will do everything you need to manage your resources, from managing memory to managing files. Excuse me, I apologize for yawning like that. And that makes it very portable language. That's what they're talking about here, about portability. I can write a Python script, which I have done recently, that I can run on my Windows machine, I can run it on a Linux machine, and if it weren't work-related, I could bring it back to my Mac at home and run it on a Mac. I don't have to worry about the fact that I have 3 different operating systems because I've written it in Python and Python takes care of that. So that's why it's portable. And it's very important. It's very, very important. And that's one of the reasons why Python is such a popular programming language, because it is highly, highly portable. All you basically have to do is have the interpreter, the same version of the Python interpreter, and the same version of whatever packages, Python packages you might be using, and you can run it anywhere. Okay. Portable file path string. So basically this just allows you to create a portable path based on the operating system rather than what we think, because we have slashes and backslashes if you're using, I can never remember which is one. If you're using Windows, you have the, I think it's the slash, and if you're using Linux, you have the backslash, but I know the direction, I don't know which is slash and backslash, sorry. But Python allows you to be even more portable by allowing you to do this thing called os.path.join. So I can have a path, and I don't have to worry about the slashes or the backslashes. All I have to do is give it the parts of the path, and it will create the appropriate file path for me. So that makes Python even more portable, because you don't have to worry about the slashes or the backslashes for file paths. I think we're just still talking about that. Walking a directory tree. You don't really need this for the labs, but it's important to know that you can. So sometimes you need to walk a directory tree to do something to files at each level of the directory tree. And Python allows you to do that. It allows you to walk the directory tree. And this just shows you the information for walking the directory tree. Binary data. Now this is very important, because not all data is human readable. And binary data is not human readable. It is used all the time. You will see things, if you actually tried to open up a Microsoft Office document in a text editor, you wouldn't be able to read it. That's because it's binary. And it's not something that we are meant to read. It's something that the Microsoft Office programs are meant to read and interpret and then make it human readable. And it just looks like a bunch of gobbledygook when you try and open it up and read it. And so you have to know, if you want to use a program that is going to write data as bytes, you have to know how to do that, and if you want to read data that is bytes. So here is a construct that Python has, and it's the B. So this B before this is a byte, this is a bytes literal, will turn my bytes into a byte string. And this is print my bytes, and what class is it? The type is that it's a class bytes. And we'll learn more about classes next week when we do objects. But there is a specific type, there is a specific class called bytes in Python. And there are certain functions you can do on bytes. Now, byte string literals, when it says that 1, 2, 3, 4, 5, 6, 7, 8, 9 is the same as this. This is what they call a byte string literal. And it is a byte notation where you are saying \x31, \x32, and you are using the specific raw byte notation in substitution for a character, because that's what that is. And I don't purport to be able to read byte notation. I have to go back and look up the bytes and things like that. And we have some data checking in the product that I work on that uses this particular byte notation and the raw byte values, and I always have to go back. I wrote the stuff 2 years ago, and I always have to go back when I'm looking at it and say, what am I doing here? So I'm not an expert in byte notation. I do know some engineers who can just look at it and read it. It's important to note that when you are doing files that are using hexadecimal values, byte values, and are using byte objects, that things may not look the way you expect them to look. And that is probably just because they need to be modified from their raw byte notation into something that a human can read. So they're just saying a BMP contains, which is a bitmap, contains binary data. So if you open up a file and you print the contents of a file, and by the way, this RB is read binary, so it's going to read the information as raw binary bytes. And you're going to get something like this, and it certainly doesn't look like the soccer ball. But that's because the programs that can read BMPs know how to interpret this data. But you will see this with BMPs and JPEGs and PNGs. Don't let it startle you. Don't let it scare you. It is simply just a different format for storing data, and it often takes up less space, especially with large imagery. You take up substantially less space when you have raw byte notation. Okay. So, command line arguments and files. So the location of the file may not be known before writing a program. So basically you can use a command line argument to tell it what file to use. So it's no different than any other command line argument. And you can just simply input it as part of the command line argument, and then you can open up the file. So in this case, basically, you're using, you're not using the user input command, you're not using the input command or the input function. You're simply allowing someone to type in, and it has become part of the object string or the argument string for the file. And you're just going to act on that file like it's any other piece of data. And there are some neat things that you can do. You can figure out if that file actually exists. So before you use a file in a program, you're probably going to want to make sure it exists, especially if somebody is typing it in on the command line. You don't just want to assume. So you want to figure out if the file exists. And Python has this great package called OS, and OS just allows you to speak to the operating system pretty directly, and it does all of the interpretation between Python and the operating system for you. And it's got all these handy functions, and this one is os.path.exist. So does this path exist? That is what that is asking. And if it doesn't exist, you don't want to try and open it. So you can say, sorry, it doesn't exist, and you exit the program. If not, then you can open it, let's say, for reading, and then you read the lines out of it, and then you close it. So that's all that this is doing. But it's important to understand that there is an OS module. That module has lots of stuff that you can do for the operating system, and it's not just about files. Okay. With. This is something I use all the time when I use files. This keeps me from having to worry about closing the file. Remember when I said every time you have an open, you have to have a close? Well, this is the exception, and it's just very handy. Basically what the with command does when you're dealing with files is that it says, I'm going to open up a file, I'm going to open it for reading, for writing, for appending, but when I am done with this code block, you close the file automatically. So when that code block is done under the with, then it does the close for you. So it does the management of the file descriptors for you, and you don't have to worry about it. And you have taken all of, excuse me, I think I'm going to sneeze. Sorry. You have taken all of your file processing and put them into their own code block. So it makes it very, very easy, and it makes it extremely easy to deal with files. And this is a good example of what you would want to do with the with statement. So with is the keyword. You always use it with open. With open, you give it the name of the file name, what you're going to do to it. And then there's an as f. So it's with open as. And then f is simply a variable that is local to what's happening in the with. So f is only valid through there. F is no longer valid when you get to that print. And basically what you're doing here is you are doing whatever processing you need to for that file. And so you can read the lines, you can do any processing, you can write it, and then when you're done, you don't have to close the file. It all happens within this with, the with open statement. I use this all the time. So let's take an example of that. So I'm going to go back to my, actually, we'll just do a new one. Oops, yep, new Python file, simple with. Okay, so I am going to, we're going to use test.txt. We've got our 2 lines. And the simple with is just going to say, with open test.txt read, actually let's do a read plus, as f, and so f is now already open, okay? The minute it gets to line 3, it's open. So I'm just going to print f here. Okay? And then I'm going to read the lines from f. So right now I know there are 2 lines, and I'm going to say line 1 is f dot read line. And then I'm going to say line 2 is, oops, equals f dot read line. And then I'm going to print line 1, print line 2, And now, whoops, I'm going okay. So let's see what crazy things I just did. So basically I use that with open, and then I'm going to do some stuff and read things out of the file, and then I'm going to print out and prove that F really isn't there. So I'm going to debug this. Actually, first I'm going to edit the configuration. A simple with. Put a line break, and I'm going to debug it. So I am on line 3, and as we can see here, F already exists. So I have, just with this one line, I have opened the file, and I have assigned it to a variable called F. Now this is one of the few instances where you have a variable that was not defined by being on the left-hand side of a single equal sign, but it only is valid for lines 3 through 9. After lines 3 through 9, it's no longer valid, and there won't really be anything in it. So I'm going to step over and look at my console. So I printed out what F is. I'm going to read line 1, read line 2, and you'll notice that this happens sequentially. So when Python is reading the file, and I just say read line, it's going to read the first line out of the file, and then it's going to move an invisible pointer from the first line in the file to the second line in the file. And it's going to wait there with that invisible pointer until another command comes in from Python. And when Python reads that second line in the file, it's going to move down. Now, it can either move to the end of the file, or it can move to another existing line. And once we're done with this, I'm going to try and read a third line and show you the error message that we're going to get. But, so I have read those 2 lines. They read successfully. So I'm going to print line 1, print line 2, and I'm all done. And now I'm going to format F, and done. F is, okay, so the pointer is still there. My bad. F still exists in this case. So the other thing I wanted to show you was line 3 equals F dot read line, and then I'm going to print line 3. Now if we go back and look at test.txt, there aren't 3 lines in this file. There are only 2. So let's see what happens when I attempt to read that line. So I'm going to read line 1. Oops, except it's not right. R-E-A-D. Let's stop this and start it again. Okay. So we're going to read the first line. We're going to read the second line. Now what happens when I try and read the third line? I don't know. Let's see what it said on the console. Didn't give me any issues. 1, 2, and 3. So there was nothing. I thought it was going to give us an error message, and it didn't, which is kind of rough. I really thought it was going to give us another. Is there a third line? There is not a third line. So where am I? Simple with. So I thought we were actually going to get an exception on this line, and we didn't. So that is something to note, that you can in fact walk off the end of a file and it won't be a problem. But that's not something you're going to have to worry about for the labs in this class. So I thought we would get an error, and we didn't. Comma separated value files. CSV. If you think about an Excel spreadsheet and you save it as a CSV, that's all it is. It's rows and columns. And we know about rows and columns because we did them with two-dimensional lists. So a comma-separated file, a CSV file, has rows and columns, and it has contents that go into cells. It's just like a two-dimensional list, and you can have files with comma-separated values. And the nice thing is you can read it in as a CSV file. And there is something called CSV. You can import a package called CSV, and you can open the file. In this case, it's just called grades.csv for reading. And you can use a CSV reader and give it a delimiter, and it will, in fact, just read all those things in for you. And then you just treat it like a list, because that's all you have to do is treat it like a multi-dimensional list, because that's all the CSV file is. And you can perform calculations. Once you have read the CSV file in, it's just a multi-dimensional matrix. It's just a two-dimensional matrix. So you would just use it like any other row and column-based matrix. So we have our word frequencies lab, and write a program that first reads in the name of an input file, then reads the file using the CSV Reader method. The file contains a list of words separated by commas. Your program should output the words and their frequencies, the number of times each word appears in the file, without any duplicates. So they have this thing called input1.csv, and it's just got all of these words in it. And they're comma-separated values, and basically what they want to do is they want you to go through and say, okay, and by the way, this is case sensitive, so lowercase hello is not the same as big case hello, just to let you know. And then it wants you to go through and say, okay, how many times does hello appear in this list that I've given it, and how many times does the word cat appear, and how many times does the word, boy appear. So that's all it wants you to do. And you would import CSV, and we can get you guys started on this one. And then there's sorting TV shows, which is dictionaries and lists. So we'll do a little bit of this one and then a little bit of the other one. And then if anybody has any questions, especially about next week's project, please chime in and let me know.
Can I ask a question about this one?
Sure.
I got to the submission part, and it's actually, then it asks for input 2 CSV, input 3 CSV. So I got it to run in develop mode, and then I got to submit, and I'm not sure how to, I guess, read in the multiple CSV files. Would I just do like a for loop, or I don't know. That's where I'm getting thrown off.
I unfortunately can't. I can look at submit mode. See, the problem is that all of the teachers share the same zyBooks instance, so we're not supposed to change anything. I will do this and hope. Okay, so so when you are submitting it for grading, yeah, see, it doesn't work the same for us as it does for you. So they give you input 1, and then when you're doing it, they're asking you to take in multiple files?
Yes, as far as I have seen, it's asking for, because it'll get to the second one it runs through, and it'll say input 2.csv, and I wasn't sure quite how to.
Does it give you an error?
Well, yeah, I can only, I can only get one answer correct because because I could pull in, if I change it to any of the other CSV files in my code, it runs correctly, but I don't know how to pull like 5 in.
I think you don't have to put 5 in. I think that instead of having like fopen input 1.csv, you just want to have an input command. So I have like file name equal input. Yeah, Brandon.
And that's just general input?
Yeah, just general input. And then zyBooks will go through and it will populate that with the name of the file. So instead of using input 1.csv in the fopen, you would just use the name of the variable that was on the left-hand side of the input.
Okay. So instead of using input 1, just use file name.
Yeah, just use file name.
Okay.
So, and if everybody's okay, I can just go on to the next one with dictionaries and lists, or I can answer questions for the projects. Sorry, where's the chat? Did I miss? Ah, yeah. Thanks, Brandon. So, show of hands, do you guys want me to go over this lab? I'm not hearing a resounding yes. Okay, I'll go over the lab. Okay, so basically, and I'm just going to use this as the list. What is this name? This is 7.8. Okay. So this is lab 7.8. And this is my, let me just do this. Okay, I'll do this. So I'm going to create a new file again. Just a file. So this is input 1.csv. Okay, I'm glad it found the plugin. What plugins do I need to install? No, I don't need those. Okay, so I created my input 1.csv, and I'm going to go here, and I'm not going to actually do it, but what you want to do is, actually what I'll do is I'll do file name equal input 1.csv. Now here, instead of equal input 1.csv, what you're going to want to do is do an input statement. So you would do input like that. Okay?
Thanks.
Okay. So for me, what I'm going to now do is I'm going to say with open file name for write as my file. So now what do I want to do? I have opened it for writing. And now what am I going to do? Well, the first thing I'm going to do is I want to figure out how to read this in. So there are a couple of different ways. I can read line. I can read, which will give me a whole big string. I can read line, which will read each individual line at a time. Or I can read lines, which will give me multiple lines, none of which is going to give me a list. So here's where I need to use the sorry. I want to read it in as a CSV, so I'm going to import. I hope that's good. Yeah, import CSV. So I want to read this as a CSV file. So let me go back and look at the with stuff for CSV. So, okay, as CSV file. Okay, so I can just use a regular open, but I'm going to use the CSV Reader and a delimiter. So, because I like copying and pasting when I can, so I'm just going to call this name equals. So we have CSV file name reader. What's the problem? Oh, that's not a comma. That helps. So I should have a list of names. And so let me just run this one through and make sure that I have what I think I have. I apologize, my computer is slow tonight. Okay. Okay. So I'm just going to run this, see if it does what I think it does. Okay. That would do it right there. Sorry. Okay, so it does what I think it does. Did it print name? It did not print name. Name equals CSV Reader, CSV file delimiter, comma. Input1.csv. Is that what I called it? Input1.csv. Open file. Name. Print name. It doesn't say anything there. There's stuff in my file. Ah, there's nothing in my file. That would be why. Okay, so let's go back down here. Word frequencies. Here we go. Sometimes you just have to make sure that you have the right data in your file. Okay, now let's try this again. Oops. Oh, does everybody see what I just did? I opened it for writing, not for reading. So every time I opened it, it cleared the file out. So that's an important lesson from your teacher in what not to do. There we go. Now let's try it again. Did I change that? Okay, so file name for reading, delimiter, comma, CSV file. Yeah, I'm not worried about that. Open file name. Make sure I have that right. Print file name. Input 1, input1.csv. Okay, and it did it for reading. And there's stuff in there. So I don't know what's going on. File name, reading, CSV file, name equal names. Probably would be better. Okay, let me double check because I'm not doing something right. Okay. Yeah, it should have been csv.reader. CSV file delimiter. Oh, okay. Let me make sure that this is right. Try it again. Okay. Try it again. I don't know what I'm doing wrong here. Anybody got any suggestions? Input1.csv. Okay. So before I do that, I'm going to just do this and make sure there's something actually in the file. So with open, file name, read, file, as. That helps. If this doesn't work, I'm probably just going to move on to the next one because I'm not sure why this isn't working. I will have to figure that out. Oh, suggestion. Thank you. No, I don't think I need, because that would mean it was a string, and file name isn't a string. File name itself is not the string. Input1.csv is the string. So I'm going to CSV file dot read line. So I'm going to see what this does. Okay, so it's something to do with that CSV Reader. And I don't know what that is. I don't know why it's having a problem reading the CSV.Reader. Let me look at it one more time. CSV.Reader. I don't know what's going on with this. So here's what I'm going to do for now. I am going to say dot split. See what happens. Okay, that did what I needed it to do. So I now have a list of strings, which is what's important here. Because what you're going to do is we're going to use our looping over strings. So for each item in the list, I want to check all other items in the list to make sure that, to see whether or not they match. And then if they do match, I want to keep the number, and I also want to make sure I don't count it again when I get to it. So I'm going to start with the first part, which is the double for loop, and then I'm going to let you guys figure out how to maintain the name and the number, which kind of sounds like a dictionary to me, and how you're going to make sure that if hello or cat or boy shows up more than once in the list, that you do not then add again to that dictionary. So we have a list, we're potentially going to create a dictionary, and we're going to potentially check that dictionary to make sure that we don't add it again. So I'm going to say for name in name. So now I have a name, and then I'm going to go for in name. Let's see, I'm going to have name counter, and then I'm going to say if enter counter equals counter plus 1, and then when it's all done, I'm going to just put a print here, add to a dictionary with name and count. So that's the basic gist of what you need to do. And before you add it, you need to check whether it's already in the dictionary. And when you're up here with names, you need to check whether or not the name is already in the dictionary. So if the dictionary doesn't have anything in it, you go ahead and count it. If it does, then if you check the name, you check this name against the dictionary. If it's already there, then you just continue. So that is the basic gist of this particular lab. Does that kind of clear it up for people? Does that help you guys understand? Okay. So I'm going to go on to the next lab. Sorry, this is word frequencies, and now I'm going to go on to the next lab, which is sorting TV shows, dictionaries, and lists. So you're going to write a program that reads in the name of an input file and then reads the input file using the file read line. So you're going to have like an input statement, and somebody's going to type in the name of an input file, and then you're going to use the read lines to get all the information out of that file. And then it contains an unsorted list of number of seasons followed by the corresponding TV show. Your program should put the contents of the input file into a dictionary where the number of seasons are the keys and the list of TV shows are the values. Multiple TV shows could have the same number of seasons. Sort the dictionary by key and output the result to a file named outputkeys.txt. Separating multiple TV shows associated with the same key with a semicolon. Next, sort the dictionary by values, alphabetical order, and output the results to the output titles.txt. So they have a file1.txt, and it has all this beautiful stuff in it. And then what they want you to do is they want you to, so 20 is the key and Gunsmoke is the value. 30 is the Simpsons. 30 is the key and the Simpsons is the value. And then it wants you to output to the output keys.txt 10 : Will and Grace 12 Murder She Wrote. And then it wants you to sort by, so this is sorting by keys, and then it wants you to sort by the name of the show. So this would be an alphabetical sort, this would be a numeric sort. And that all comes from this amount of data. So let's just give this a quick try. So first, I'm going to create file1.txt. And I'm just going to copy all that stuff in it. So there it is. This is lab. Okay. So there's a couple of things going on here. So the first thing is we have to read the file. And open and read the file. And then second, we have to into dictionary. Then we have to sort by key, which is a number. Then sorted data to, and then we need to sort title, not sorty, sort. So we got a couple things going on here. So the first thing we need to do is we need to open and read the file. So with open, I'm going to say, we'll do this file name here again. Oops, gotta get the quotes right. Okay. So with open, file name for reading as file. And so I'm going to now, they told us exactly how they wanted us to read it. So if we go back, it says, read the input file using the file.readLines method. So we know we're going to get back a list. So I'm going to say contents equal file.readLines. And this gives me a list. So luckily this file is managed in such a way that I can have that the first line is the key and the second line is the value, and the third line is the key and the fourth line is the value. So I know that odds are keys and evens are values. So I can say, because I now have a list. And the nice thing here is also, actually, I think what I'm going to do is I'm going to say contents, C-O-N-T-E-N-T, contents equals nothing. Because I just want a variable value here. So I'm going to say contents equal file.readLines, and then I'm going to print contents, and then I'm going to get out of the with, because I don't need to keep this file open any longer. That's another thing you need to deal with when you're starting to work on programs. How long do you need to keep that resource around? I don't need to keep the resource around any longer than opening the file and reading it into a variable. So I've now got it in this thing called contents, and actually I'm going to do this. So let's start with that. I'm going to change this. And again, this is my baby steps methodology. Take it slow, get one thing working, and then move on to the next. So the first thing I'm going to get working is the fact that I can read a file. I can read this file and it comes out as a list. So I'm going to run this, and that's exactly what happens. Now here's a few interesting things. One is I have all these beautiful little new lines that I'm going to want to get rid of. And two, that it's a list. So if I do read lines, let's say, if I can't do that because it's not a string. So I'll have to strip those later. But now contents exists outside of the with block. So I can now access it here. So to put the contents into a dictionary, the first thing I'm going to need to do is I'm going to create the dictionary. So I'm going to say is an empty dictionary. I'm going to now go through the list for in contents. And so if it's even, sorry, if it's odd, actually that's not what I want to do. For counter in range 0, comma, len of contents, if counter crap, drawing a blank on even and odd, my bad. So if counter onto 2 is 0, then it's going to be a value, else it's going to be a key, so I'm going to have key, value, value, and then when I have a key and a value, I'm going to say dict dot dict, oops. So this is going to be, oops, value equals content, oops, let's make it readable, contents of counter dot strip new line. So I don't want those new lines in there. And the same with key. And then I'm going to add it to the dictionary. And let's just double check. Let's double check, and I promise we won't go more than a couple more minutes. Not dictionarily, dictionary. Okay. So let me just double check that I'm adding it right. And that's not what I wanted. Oh, yeah, that's what I wanted. So I'm adding it correctly, just like to double check. And so when I am done in this loop, I should now have a dictionary. So let's take a look at this. See what happens. Okay, so I have a dictionary, and my dictionary is not right. My dictionary, I did not do my odds and evens right. So my key, so this would have been counter in range 0 to line contents. So I have all, no, it's off completely. It should have been 20 Gunsmoke and not 12. So that was just wrong. Okay. Let me go back and just check on Python odds and evens. Oh, that's a good idea. Oh, good idea, Brandon. Very good idea. Let's try that. 2. So it will now go, and then each time I get there, very good, thank you. I could not think of that tonight. Oops. Undo. Okay. So, and this will be counter plus 1. So this is going to be counter plus 1. That's a much better solution. Thank you very much. So let's try this again. See what happens. That's just beautiful, Brandon. Thank you very much. I was drawing a blank. So I have a dictionary now with the correct key value pair. So now it's just a matter of sorting. And there are different ways to sort. So let's go back and look at Python. Python sort a dictionary. So here are some good sort Python dictionaries by key or value. And I'm kind of doing this on purpose. I want you guys to be able to go out and look and find resources. So here we have an example of sorting it by a program that sorts it by for I in sorted, key values print. So that's just printing it. So, okay, that's not what I wanted. Sort the keys and values by alphabetically. Okay, so that's the input. So that's the input. I don't know what they're doing. So I'm going to go back and find a better resource. So let's take a look at this one. Okay, so this looks pretty reasonable. So basically I'm going to go through the keys in my dictionary, and I'm going to determine if there is a way to sort it. Now there might also be a way, because keys actually gives me the keys. I might just be able to use the sort command, the sort function. Because Python has the ability to sort a list. So the question is, do I have to go through and sort a list on my own, write a sort algorithm, which is not something I want to do, or can I just, and it looks like I can just sort it. So let's give that a try. So the first thing I'm going to do is I'm going to say sort by key. I'm just going to create a brand new dictionary called sort by key. And then I'm going to say sorted. Actually, I'm going to say keys is dict.keys. And now I'm going to print keys, just because I want to see what's happening. So here you have a list of keys. So that's pretty good. And so now let's see how I access that. Okay? Oops. Let's see how I access that. So I should just be able to do a sort on it. So let's try that. So I'm going to just print keys dot sort. Nope. Nope. So I got to figure out how to get that, because what they're saying here is that for K and dict keys. Okay. Let's try something else here, just to see. Dict keys. Oh, Brandon, are you coming to my rescue again tonight? My brain is not functioning. Dict keys dot sorting. I don't know. Let's try it. So the problem was that I couldn't actually get from keys to the value that was in here, to this list. So what I'm thinking about doing, let me go back and look one more time. By the way, this is how I solve problems. For some reason, I lost visual. I'm going to try and rejoin. Okay, cool, Brandon. So, by the way, this is how I, especially when my brain is foggy like it is at night. Okay, so sorting a dictionary. Print sorted dictionary of names. Hello. Okay, that's not what I want. The sorted function. Okay, well, let's try that. Let's just do this. Let's just print, see what happens. Get rid of that. And we're going to go. Okay, so this is really great because I just did a sorted and it gave me back a list in sorted order. So I can say sorted keys is that, and then I can just do a for and create a, what they want us to do, they want us to output it to that. So they want me to output it to keys, output underscore keys.txt. So I can then write this to a file. So I'm going to say, actually, I'm going to put this on the outside with open my bad. Yeah, sorry, my brain is fried. Output keys.txt for writing as out1, and then for each key in sorted keys, I'm going to out1 dot write what is it? It is going to be the key, colon, space, the value, dot format of key, key, Victor key. So this should actually finish the first half of that program. So let's do this and just double check and see what output keys does. And output keys does that, except that I'm not giving it a new line. So then I have to add a new line. We'll try it again. So this does the first portion of that challenge. And it gives you basically what you need. And we also went through the process of a foggy-brained teacher figuring out how to do this. So we have a file name because you're going to have an input. I created a variable called contents. The contents are going to be a list. In fact, they're going to be this list. And then I need to then go through and create a dictionary. And thank you, Brandon, for the comma 2. I was drawing a blank on that one tonight. So I go through the dictionary and I put the key and value pairs together and add them to the dictionary. And this is just a print of what the dictionary comes out as. Then I have a sort by key, which I actually don't need anymore. I don't have to have a place for that. So I now create sorted keys, and I use the sorted function on the dictionary. So it gives me back the keys that have been sorted, and then I can simply do a with open. So I open up outputkeys.txt, and I use what was in the sorted keys, and I output. So now that gets this part of it. So now I'm going to leave for you to sort it by title. So my guess is that if you go to the sorted command, the sorted function again, we will find something in sorted to be able to sort by the values instead of the names. So my guess is you can use sorted and get the next section finished. But you would do something very similar to this. Once you got the sorted by values, you would simply output it to the right file. So I'm going to stop now. I think I've kept everybody and myself on long enough. If anybody has any questions, please let me know. 2 shows ran for 20 seasons. I'm not done with this lab. It's a tough one. Thank you so much for the help. Not a problem, Brandon. I will be posting this stuff tomorrow, and reach out to your professors. Hopefully this will be up. They'll have everything up tomorrow too, and I will talk to you guys later. I'm going to stop the recording, and there will be one more session next week. Yeah, one more session. Wait a minute, is this Module 7? Yeah, there'll be one more session next week for Module 8.